Your old car isn't dead. It's just waiting to be reborn. Witness the violent 3,000-degree journey.
Truck 402 on the scale, gross weight check. Hold your position.
We need more density in this heat. Pull 5 tons from the heavy melt pile and top it with busheling.
To ensure a proper melt, heavy structural steel is layered into the middle of the charge bucket. This heavy melt drives the process deep into the furnace bath.
Once loaded, the charge bucket travels to the melt shop. Here, the raw scrap will meet the electric arc.
Roof is swinging clear. Stand by for charge number 1.
Once the solid scrap collapses, the furnace holds a flat bath of liquid steel. The temperature now approaches 2,900 degrees Fahrenheit. Carbon is injected to create a foaming slag. This thick blanket insulates the arc, capturing the heat within the metal and protecting the furnace walls from damage.
Probe is in. Let's get a chemistry reading before we tap.
Here at the LMF, the gentle bubbling of argon gas reveals the bright eye of the molten steel, ensuring temperature uniformity.
Precision is everything. The steel must reach exactly 2,950 degrees. Too cold?
Refining complete, the ladle is lifted to the casting tower, the highest point in the mill, where gravity will take over.
Turret is swinging. Prepare to open the slide gate on ladle 4.
The steel strand, now a solid shell with a liquid core, exits the bottom of the mold. It travels through a curved arc of support. As the strand exits the curve, powerful withdrawal rollers apply immense pressure to straighten the steel into a continuous, flat slab.
Traveling torches clamp onto the moving strand, slicing it into specific lengths to create individual slabs ready for the rolling mill.
Zone 3 temp is holding steady at 2200. Keep the pacing at 2 minutes.
Vertical edgers maintain precise width control, preventing the steel from spreading beyond the customer's specifications. Automated inspection systems scan the surface at over 40 miles per hour, identifying even microscopic defects in real time.
Coiling temp is coming in hot. Engage banks 4 and 5 to bring it down to 1100.
Each finished coil weighs approximately 25 tons. This single unit contains enough steel to manufacture the chassis for 30 mid-size sedans.
The coils are moved to cooling yards where they will sit for up to 3 days. They must reach ambient temperature before they can be safely shipped or processed further.
Coil 409 is loaded, weld is complete, ramping up line speed to 300 feet per minute.
The bare steel is highly reactive. To prevent oxidation, an electrostatic oiler applies a micron-thin layer of protective oil to the surface.
The result is a hot-rolled, pickled, and oiled coil. Clean, precise, and ready for automotive stamping or pipe manufacturing.
Thread speed is set, gap setting is 0.03 on stand 1. Watch the tension profile.
Cold rolling makes the steel extremely hard but brittle. To restore flexibility, the coils are stacked and baked in a 100-atmosphere furnace at 1300 degrees. A final pass through the temper mill gives the steel a slight extension, locking in the surface finish and preventing defects during customer stamping.
Pot temp is holding at 860. Dross levels look good. Keep the line speed steady.
The coated steel travels vertically into the cooling tower. Here, the liquid zinc crystallizes, forming a metal.
A final passivation treatment seals the surface, preventing white rust during storage and ensuring the steel arrives.
Arbor alignment looks good. These cuts need to be exactly 10 inches for the stamping press. Here's the MTR, ma'am. Just need your signature right here, acknowledging receipt of the steel.
All right, got it.
From a rusted scrap heap to a gleaming new vehicle, the American steel cycle is a triumph of engineering and recycling.
And in 20 years, this steel will return to the furnace, ready to begin the journey all over again.